Kurniawan. I am a chemical engineering student on the University of Sriwijaya. In this video, I will show you how the elasticity works in the archery, and I will show you how to analyze the elasticity on the archery. So guys, if you're excited about this kind of topic, let's go into the video.
So guys, in here we're gonna calculate the strain and the velocity of the arrows with two cases. In the first case, we strain the rubber until 5 cm, and the second case, we stretch the rubber until 10 cm. So here the first case. As we know, in here we're gonna stretch the rubber until 5 cm. But before that, we should measure the rubber before we stretching it. Here, we got the 17 cm for the initial length, and after that, we stretch the rubber on 5 cm. And of course, we should measure the rubber after the strength. On the first side, we got 10 cm, and on another side, we got 10 cm too. So, we got a 20 cm as the length after we stretching it. Here, we're gonna calculate the strain from the data that we get. From the data, we know that the initial length is 17 cm and the length after stretching it is 20 cm. So the delta L is 3 cm. To calculate the strain, we use the formula that E equals delta L divided by L. We put in all the values, so we get 0.17. Here, we're gonna shot an arrow into the target with 0.17 strain. After we shot an arrow, now we can calculate the velocity. We know that the distance is 45 cm. We calculated 2 meters, so we get 0.45 meter. We know the time is 0.9 seconds. We use the formula that velocity equals distance divided by the time. So we put all the values together and we get the velocity is 0.5. Here the conclusion from the first case, and this is less successful. Now we'll continue to the second case. In here, we're gonna stretch the rubber into 10 cm. But before that, we should measure the rubber before stretching. Here we got 17 cm as the initial length. And after that, we stretch the rubber. And of course, we measure the rubber length after we stretching. On the first side, we got the 13 cm. And on another side, we got the 13 cm too. So we got a 26 cm. From the data that we get, we can calculate the strain. So from the data, we know that the initial length is 17 cm and the length after stretching it is 26 cm. So the delta L is 9 cm. In here, we use the formula that E equals delta L divided by L. We put all the values together and we got the 0.34. Now, we're gonna shot an arrow into the target with 0.34 strain. Is it gonna be successful? Let's see. Yeah, it's successful. Let's see once more. Now, we're gonna calculate the velocity. From the data, we know that the distance is 45 cm and we change to the meters, so it's 0.45. And the time is 0.4 seconds, so the velocity we're using the formula the same as the first case. We put all the values together and we get the velocity 1.125 meter per second. So, from the second case, we can conclude that with 0.34 strain, we got 1.125 velocity, and it's successful. And here the final data from two cases. We got a strain, time, and velocity.